With great bodies of water come great natural hazards beyond the control of humankind. These phenomena primarily present as natural hydrological events and only become a hazard should these pose a threat to humans and their surroundings. Two of which with recorded impact on the history of the Earth are storm surges and tsunamis.
The National Geographic Society defines storm surge as an abnormal rise of water caused by severe tropical cyclones, categorically called typhoons or hurricanes. A storm surge is created when the force of a storm's winds pushes the water towards the shore. The direction of the storm's winds is steered by the Earth's rotation, a phenomenon known as the Coriolis effect. The severe flooding near coastal areas from when a storm surge is created have caused thousands of lives and millions of economic and environmental damages. Famous occurrences include that of the 2011 Typhoon Pidring on the local scale, which destroyed the seawalls of Manila Bay, and the 1970 Bola cyclone on the international scale, which claimed the lives of 500,000 people.
On the other hand, a tsunami is defined as a cataclysmic wave produced by undersea earthquakes and volcanic eruptions. These often occur in bodies of water with active submarine earthquake zones. The sudden displacement of the ocean is caused by converging tectonic plate boundaries. Those residing in coastal areas are inevitably at risk of severe injury and death. A notable record of tsunami in the country is that of the Moro Gulf earthquake with a magnitude of 8.0, its 9-meter height ending the lives of 4,381 people. On the international scale, that of the magnitude 9 earthquake producing a tsunami that swept at the Hokkaido region of Japan in 2011. On November 2nd of 2013, a low-pressure area is seen to develop east of Micronesia. It then only took 2 days of intensification for it to now be classified as a typhoon. Forecast to hit the Philippines, Typhoon Haiyan further intensifies into a super typhoon on November 6th, with Pag-asa raising storm signals 3 and 4 in eastern Visayas and Mindanao. Super Typhoon Yolanda finally makes its downfall in Guiuan, eastern Samar at 4:40 a.m. on November 8th, with Pag-asa having recorded its maximum sustained winds of 235 kilometers per hour. The aftermath of the typhoon came in the form of houses washed away by the waters and visibly wrecked infrastructure. The National Disaster Risk Reduction and Management Council releases a final report with fatalities totaling 6,300. Up to 1,800 people are reported missing. Overall cost of damage in property and other infrastructure amounts to a total of 95.5 billion pesos.
Then, ako nung nag-hit yung Yolanda. Yung hometown namin nun, yung bahay namin malapit lang sa dagat. Maraming puno nun natumba. Tapos meron kasi nun yung ginagawang mall pa lang sa amin. Kasi hindi pa siya tapos. Parang nasira siya ng typhoon. Tapos kahit parang tapos na yung bagyo ko nun, ready pa rin kami ng yung sa mga pagkain pa din. Baka parang aftermath na tsunami ka nun.
During the aftermath of Super Typhoon Yolanda, there have been reports of the public interchanging the terms storm surge and tsunami, whilst talking about the disaster caused by the rising water levels during its onslaught. As discussed earlier, a storm surge is primarily caused by a cyclone's winds. Meanwhile, a tsunami is caused by submarine volcanic activity, earthquakes, or landslides. As quoted from former DOST Secretary Mario Montejo, the people's organized evacuation in preparation for the storm surge requires around 24 to 48 hours, while tsunami alert required at least 30 minutes of organized evacuation. The hydrological hazard brought by Super Typhoon Yolanda is therefore a storm surge.
The victims of Yolanda continue to face the seemingly permanent road to recovery. And although measures such as the Comprehensive Rehabilitation and Recovery Plan of 2014 was approved to aid in the recovery through resettlement and livelihood, until now, around 90,000 housing units are still left unfinished, and government support on livelihoods in agriculture remains unseen. Science communication is a variety of practices that transmit scientific ideas, methods, knowledge, and research to non-expert audiences in an accessible, understandable, or useful way. In its most vital use, science communication helps ensure that natural hazards and their corresponding risks are understood by underprivileged and marginalized communities. The acquired understanding of these natural hazards also aid in the furnishing of disaster risk management plans by local government units, which boost community preparedness. Lack of effective science communication on natural hazards is detrimental to the people in affected areas. In the case of Yolanda, those who were affected more widely attached the concept of high ocean waves to tsunamis and water level to body parts or building floors, leaving them with little idea of the dangers of the storm surge.